In this section of pages, I will do the Gantry assembly. To able to print this assembly, I need to print all of this part, but unfortunately, this part have this curved feature on the bottom side used for the seatbelt teeth to sink into. If I printed this part as is, the curve will be filled with resin, hardened resin. I have tried to lower the bottom exposure and it's still having the same result. So I decided to modify this part. Yay, open source! I decided to make the curve with its screw hole its own insertable part of the drive hardwares. I made the insert 2 mm intake, one more than the device curve. To make this, what I need to do first is to turn the insert shape, constrain it, then extrude it to 2 mm down and 0.1 mm up. I created clone of this part and the drive assembly, one from the part and the other from the insert. For the insert, I created intersect boolean, and for the part, I created cut boolean. Since I had used 10 mm belt, I enlarged the belt to a tad bigger than default. After it all was done, I exported all into my slicer, and this happened. I do not know why the drive part chamfer for the screw hole gets separated, making the part broken. So I tried to fix it by using Blender. No, not those spinning tool on the kitchen, but Blender 3D, the 3D animation software. What I'm doing here was extruding some edge to make it intersect with other face in hope that my slicer will fix the rest. But nope, it don't. And I need to stitch the face manually. Well, at least I need to stitch it on only certain places, and not all. After I finish fixing said part using Blender, I proceed to print that part, clean, and before plugging the hole, I insert in the insert by first removing the support and then grabbing excess plastic from the part and the insert using blade. Next is gluing said insert to the part using CA glue. Then plugging the hole and filling it like usual. This time, I use a resin thinner to make the bubble go away. Well, small bubble only at least. Next is the hardware, starting from the idler bearing. I wash this part using acetone, then let them soak in the tissue paper to dry them, then oiling it using the usual oil. Then, stack them according to the idler instruction, doing the maneuver they specified inside manual. It was tricky to do that. Sometimes either the whole stack or part of its shift, making the boat unable to go through. And usually, I need to restack them again. Oops, upside down. Well, we do it again. Now, the drive A or B, I honestly do not know. Its main user contains either and drive pair for either A or B side. For this assembly, I also expanded a bit to just print and skipping the mass editing part. And the result was that I could just punch the hole through without any problem. Well, time wasted on the blender, I suppose. Next step that I did is to check which one is the top part. After it's found, I insert input screw and proceed to stack the idle assembly as per instruction. I was debating beforehand, just off camera unfortunately. But here is what I did. Just chuck them in the acetone, shake it, then pat it dry with tissue paper and oiling it using the usual after that. The stack is complete now. Tighten the axis screw and let's slide into the stepper motor assembly process by first mount the drive pulley and spacing it with the tool they provided and tighten the set screw. Then attach the motor to the drive part and insert in the screw. Well, it won't go in because the hole is filled with split resin, so I need to enlarge the hole using file. I ended up filing all the hole just in case. Attach it and while oiling it, I noticed that one of the bearing is upside down. And no, I won't disassemble it. I just loosen the axis code, then flip the bearing in the equation and call it a day. Okay, the next thing that's in my attention is the XY connector piece. Starting by releasing it off the bed, then oh look, a tab resin. Well, it's wasted now. Then starting the reciprocal part on the printer and give this part a clean. While cleaning it, I need to break the tab resin so I could finally get it out, then thoroughly clean this part. And yes, I need to change the cleaning instruction, but nah, it's fine. Just rinse it with IPA from my wash bottle and it's good to go. Then drying it using tissue paper. Next is plugging the breathe holes and it's filling time. This YX connector took so much resin and I need to make second pass to fill this thing completely. I can avoid that this thing becomes too heavy for the Gantry. I noticed that these parts are leaking mainly from the screw holes, and yes, I have to put the hole there just to make resin able to drain back into the fan. I also noticed that one of these parts have a big hole. This happened because my resin is just too weak in layer addition, I guess. I have no problem bending all of those painted parts with the same setting, only this time it caused problem. Or perhaps my resin is just too old. I bought it expired, hence I get it so cheap. The disadvantage of using expired resin is its consistency, or lack thereof, according to my resources I found on the internet. I noticed that big hole in the cleaning phase and I decided to plug it with CA glue and some tissue paper. The tissue paper used as a structure for the CA glue, then gave it extra 1 to 2% the cure time. But by mixing for second batch, I noticed it leaked and by now it's already too late.
Leaking. Fuck, it is. Aduh.
I tried to patch it in the filling process, but it still leaked, so I just let it cure for a few hours until said acid is more viscous, just like forbidden honey. Then, I scraped said honey like resin using plate and wiped the rest of it using cotton soaked in the acetone. Then let it cure further again until the resin is in rubber like state. It's time for the second batch. Third batch, I do not know. It depends on your count. Of course, before doing the second or third batch, I patch the hole again with CA glue, then inject the resin and wipe any split resin. Then let it cure. All part I ready now. It's time to assemble them. Starting by the y-axis rail. Unfortunately for me, the tape left some residue and I need to clean it using acetone and tissue paper. Next I did is to install the screw and the T-nut for the rail. I did it like that, inserting the screw to the rail, then put the screw and rail on top of the nut, then screw the screw. Repeating for each screw. It's surprising to me, but I think I forgot to clean the rail off. The tissue is still damp with acetone, probably the former. Anyway, I oiling it using the usual like those Z-axis rails, just to prevent rust. Then slide it to the extrusion leaving 10 mm cap of the edge of extrusion C. Extrusion for Y-axis. Center it using the tool, then tighten the screws. I tighten it from the middle outward. The other side is that of camera. Sorry. The way is finally finished now. It's time to install the Y-rail extrusion to the idler. The instruction asks for the idler to be flat with the extrusion, so I use her as a straight edge, then keep these two aside. Next is to assemble the drive A and B to each other by linking them to the aluminum extrusion E, the shortest one. Stacking by slide in the nuts from the top and bottom side, then slide the B side to the left hand side into the aluminum, insert in the screw and tighten it. Repeat for the bottom side. Repeat for the other side as well. Oh, every time you see me tapping this aluminum profile with the X key, what I'm doing was to make the nut slide ever so slightly by vibration alone. Next is the YX connector piece. I'm a bit confused on how this is supposed to be assembled by watching the manual only. I tend to mount the top and bottom piece backward to each other. While assembling the part, I need to orient match what's on the manual and what's in the real life. For the reciprocal piece of this part, I assembled it off camera. Sorry. Okay, here's our first major issue. See these two items? They look alike, don't they? Well, they are different if you look at them close enough, and I found out that the hard way. I thought that I could get away with the only modify and win one part of this, but nope, I need to modify both of them. I need to disassemble those difficult parts and reassemble it again. Yay! The next thing is to choose the Z clip. There are bubble, and bubble, and bubble, bubble anywhere. I won't know bubble because the spot is in a big stress and it have bubble because the injection issue. I accidentally injected bubble to it and I can get that out now. After choosing the chosen one, it's time for our matchup assembly. I slide in the rail extrusion to the drive part, then set the T-nut for the top side and adding the seatbelt clip and tighten the screw. And in the middle of assembly, I
Oh, I forgot.
The block. The block. The linear block. Ah.
Well, it's time to disassemble a game then. To assemble the block, first I loosen the cleaning flap of said block on both sides, then slide it from the plastic carrier to the wheel, and vigorously slide it back and forth on the wheel, and we tighten the cleaning flap again. After it finished, then I shift my attention to the X carriage by first cleaning the MGN12 linear wheel and its bearing off the shipping grease, then we loop it using the new grease. I use generic one by the way. To install the wheel to the extrusion, first I need to install the screw to the wheel and screw it to the T-nut, but just barely. Then set the wheel in, leaving 10 mm gap of the edge of extrusion D. Extrusion for X-axis. Then tighten the screw all the way. After the wheel was secured, next it is block. I clean it using the acetone, similar in the way that I clean those MGN9 blocks. Then give them some grease, distribute it, adding a bit more and attaching the block back to the rail. It's a bit snug at first, but after loosening the flap, it started to slide easily. Then, we tighten those flaps. After all of that, I attach the XY connector piece by first slide down the T-nut, then slide the left-hand piece, then I attach the top screw. The vessel doesn't want to get in, so I loosen some screws a bit, and the piece just slide down with a little persuasive action needed. Then, I attach the top screw. Well, forgot the top nut, attaching it, then I do not want the drive mount chain to break while I'm manipulating this thing around. So I use zip-bed clip as a temporary replacement. At the time of assembly, I do not have 15, yes 15 and not 16 mm screw available and I want to see this piece complete in this video even though partially. So I improvise a bit by using empty by 20 mm and attaching some washers to it. It looked janky, but hey, it works. While insert in the screw can slide into the hole because said hole is filled with split resin from the previous step of this build. So I need to find the hole to make the gap bigger. Next, and the least thing for this video is to insert the X carriage by screwing the XY connector to the Y-axis linear block. This is how it looks now. And I think that's it for now. It's long already. I'm on the B page of the script. Well, join me next 2 weeks from now for the part 2 of this Gantry, which I will install the belt for all axes plus extra stuff. Thank you so much for watching. Well, later getters.